This is independent practice part 2. You can check your answers, see how you're doing. Let's look at number 5 first. It says determine how the next term in each sequence can be found, and then find the next two terms. Okay, so I'm looking at 4 to 16. It's either plus 12 or times 4. Let's start with times 4. 4 times 4 is 16. 16 times 4 is, like 50-something, so it's not that. So 4 plus 12 is 16. 16 plus 12 is 28. 28 plus 12 is 40. So it's plus 12. That's how I get each term. Now, if I want to find the next two, 40 plus 12 is 52. 52 plus 12 is 64. Okay? Let's look at this one. 1.5. Okay, I don't think it's going to be multiplication. I think it's adding. So 1.5, what am I adding to get there? Plus. It's going to go up. Well, I'm going to subtract them to find out. 3.9 minus 1.5, that'll tell me how much it's going up by. My decimals are lined up. 9 minus 5 is 4. 3 minus 1 is 2. So I think it's going up 2.4. Let's check that. 1.5 plus 2.4 is 3.9. 3.9 plus 2.4 is 6.3. 6.3 plus 2.4 is 8.7. So it is adding 2.7. Now I'm going to do 8.7 plus 2.4. Line up my decimals. 7 plus 4 is 11. Decimal point. 8 plus 2 is 10 plus another one is 11. So the next one is 11.1. And then if I want one more term, it's going to be 11.1 plus 2.4, which is 13.5. Okay. Let's go to 17. Ooh, we got fractions. Okay. So I know that 2 1/4 to 2 3/4 to 3 1/2 to 3 3/4 is that it's going up by something, adding something. And it's not adding a lot. It's adding 2 to 2, that's nothing, but 1/4 to 3/4, I'm adding 2/4 every time. Okay? Or you could say I'm adding 1/2. So 2 1/4 plus 1/2 is 2 3/4. 2 3/4 plus 1/2, or 2/4, equals 3 1/4. And then that plus 2/4 is 3 3/4. So now I want to find the next two. I'm going to go 3 3/4 plus 2/4. Okay? So it's going to give me, well, I'm going to put it into a mixed fraction when I'm adding these. 3 times 4 is 12, plus 3 is 15. 15/4 plus 2/4 equals 17/4. Now, I want to make that into a mixed. I mean, this was an improper. So let's take my improper into a mixed. 4 goes into 17 4 times. 4 times, that'd be 16, and that leaves me 1/4. Okay? Now, I'm going to add 2/4 to the 1/4. So let's erase this. And I'm going to go 4 1/4 plus 2/4. Make this into another improper, which is 17/4 plus 2/4 equals 19/4. Now 19 goes into 16. So 4 times 4, and then that leaves me with 3/4. So this would be the next one, and then the one after that is there. It's a little tricky, especially with fractions. But you're adding 2/4, and those are the next two. Okay, number 8 says, just find the missing number in each sequence. So, there's going to be a little guess and check here. I know that 30 to something to 19, it's getting smaller. So I'm subtracting something, because then 19 to 13 is subtracting 2. Now, I don't know what this is, but I do know I could figure out what 19 minus something will get me to 13. So I'm going to actually do that. 19 minus 13. And for simplifying it a little bit, I'm going to make it into a decimal. 0.5 is the same as 1/2. So, and I like to do that this way. 19.0 minus 13.5. Okay, my decimals are lined up. 0 minus 5 I can't do. That becomes an 8. That's a 10. So that's 5. 8 minus 3 is 5. 1 minus 1 is 0. So it's going 5.5, or I can convert that back to a fraction, which would be 5.5. Okay, so now I'm actually going to keep it as a decimal for now because I want to make it easy. 30 minus 5.5. I have to have decimals lined up when I'm subtracting. So 0 minus 5, I can't do, can't borrow from here. This 3 becomes a 2. This becomes a 10. Now I can borrow from it. It becomes a 9, and that becomes a 10. And you could do this on your calculator too if you want. 10 minus 5 is 5. Decimal drops down. 9 minus 5 is 4, and 2. So this number is 24.5. I could test it one more time to see if I get down to 19. So I'm going to take 24.5 minus 5.5. That's a 0, decimal point. Can't do that. That becomes 14. That's a 9, 1. 19, which is exactly what that is. So it's great. 24.5 or 24.5. Let's look at this sequence here. Ooh, decimal. Okay. Again, it's going down. So I know I'm subtracting something each time. I just need to figure out what. So I'm going to do 43 minus 0.8 minus 36.7. This will show me what the difference is. So, line my decimals up, drop it down. 8 minus 7 is 1. I can't do that. That becomes a 3. That becomes a 13. And it's 7. 7.1. So 36.7 minus 7.1. See what we get. 7 minus 1 is 6. Drop my decimal. That I can't do. That becomes a 2. 16. That's 9. And 2. So I'm going to say it's 29.6. But I want to be sure. So I'm going to take my 29.6 and subtract another 7.1. This should get me this 22.5. Let's try it. 6 minus 1 is 5. Bring down my decimal. 9 minus 7 is 2. And bring my 2, which is the same as that. So 29.6 is correct. All right, let's do these. State whether each sequence is arithmetic or geometric. Then find the next two terms. Okay, so this one is plus or minus, and this one is multiplication. So if we're going up, it's either adding or multiplying. So 1 to 6, maybe I'm adding 5. 6 plus 5, oh no, it can't be that. So it has to be multiplication. So what times 1 times what? I think it's times 6. 1 times 6 is 6. 6 times 6 is 36. 36 times 6 is 216. It's multiplying, so it is a geometric, and it is times 6. So the way I can find the next two is I'm going to go 216 times 6, which gets me 1,296. And then the next one would be 7,776. Okay. All right, let's look at this one. If I'm adding, it's going up. So if I'm adding, it's arithmetic. If I'm multiplying, it's geometric. 0.575, then I have 1.75, 275, 375. Ooh, it looks like I'm just adding 1 each time. So 0.75 plus 1 is 1.75, plus 1 is 2.75, plus 3. So it's adding makes this arithmetic. Okay. Now I need to find the next two. So 3.75 plus 1 is 4.75. 4.75 plus 1 is 5.75. That's a nice easy adding of decimals. Okay, let's look at number 12. I know it can't be multiplication. This cannot be a geometric. Anything times 0 would have to be 0, but it's 13. So, right away, I know that it is arithmetic. I'm not writing very neat, but hopefully you can tell what that is. Arithmetic. Now, it's 0 to 13 is plus 13. 13 plus 13 is 26. 26 plus 13 is 39. 39 plus 13 is 52. 52 plus 13 is 65. Okay. One more to go. Number 13. Bring it up here. J is stacking cereal boxes to create a stored display. The number of boxes in each box, or in each row, are shown in the table. So in one row, I have 4 boxes. In 2 rows, I have 6 boxes. 3 rows, 8 boxes. 4 rows, 10 boxes. 5 rows, I need to figure that one out. Is the pattern an example of an arithmetic sequence or a geometric sequence? Explain. So 4 to 6, is that multiplication or addition? I'm going to say it's adding 2. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 2 is 10. Okay, so it's adding. I know it is an arithmetic sequence. Okay, now I need to find what this one is here. And if it's adding 2, it's pretty easy. 10 plus 2 equals 12. Okay, arithmetic sequence, and I get the answer of 12 boxes. Okay, if you have any questions, come see me and we'll figure it out.